Going live. Hello world. We are doing LeetCode practice. Medium level, month 2. And then today we will take this problem. It's about linked lists. And I like linked lists. I don't know. I haven't looked into details, but let's do that. So given the head of a singly linked list group, all of the nodes, group all of the nodes with odd indices together, followed by the nodes with even indices. Okay, odd, 1, 3, 1, 3, 5. Okay, and then even indices. And return the reordered list. The first node is considered odd. The second node is even, and so on. Note that the relative order inside both the even and odd groups should remain as it was in the input. You must solve the problem in O1 extra space complexity and ON time complexity. So without using extra space, essentially. Yeah. The number of nodes is in the range 0 to 10 to the power of 4. And the values are, okay, in this range. Okay. So basically, if the length of the linked list is less than, if we have more than 2 values, then there isn't something to do. Otherwise, if there are these corner cases, which we might need to take care of, but essentially, to use any extra space, I'm thinking we could use, we could go over the linked list. So that's like one, this, 2, 3, 6, 7. So 1. I'll just draw this 1. Then we'll have 1, 3, and 5. And then we'll have 2, and we'll have 4, as the even, and we have 2, 3 odd ones. And they are connected by the way, their connections don't matter, but and eventually we want to have 1.5 as a result of 1.5, yeah. 1, 3, 5, 2, 4. So I want to have this 3, 5. Okay, how can we do that? So if we know there is more than 2 values, oh, the thing is, we'll need to connect, yeah, all the odd ones is 5, is where we will connect all the even ones, okay? So we might want to go to the end first, check the length, and at the same time get the pointer to this end. To the end. The end will be also a node, yeah. So if we know that, we will be extracting then odds and even ones. We'll just have that and in keeping that and. And by the way, that and could be even or odd. I don't know if that matters much. If it's odd as in this case, yeah, it's the end. But if it's even, like if it was for, it's still gonna be, oh, then it's not gonna be the last one. No, we need to grab the last odd one. Yeah, the last odd. So last odd. If we know the last odd, that's where we'll be collecting them. Yeah, we'll have, and odd ones will be attached. We will essentially have 2 lists, okay, just to understand. And 2 lists. One will start with the head. Eventually we'll return head. But we need, before we do that, we need to say that this ending one which will be this last odd. Yeah, so we'll be building, essentially we'll be building those lists on head, one list, and then the last odd. The head will be our, yeah, so these are our even, these are odd, and these are our evens, yeah, odds and evens. Odd value, odd and even. and then we'll connect them. So we need to find that last odd first. It's our first. Once we have it, we'll go 1. Yeah, the even ones will be connected to the here to the second list, and odd ones to the first list, and that's it. I think that's kind of the approach. An approach here. So we do need to go over we'll be counting. When we go for the first time, we don't want to change it. But when we go for the second time, we'll start relinking them. By the way, we can, just for clarity, we can say that even is had, okay? Oh, the opposite, odd is had, and even, we don't know, even is gonna be the first even one, and we also remember the last odd. Yeah. Essentially, it's like that. We don't know what that even is gonna we can just create we can create a dummy list node, even say that it's a list node, and will be at the end, once we have our last we'll also have our last that last odd next will be that even. Next, because we don't need the dummy, we can just So, but we'll have a runner until runner is not for runner is not nil. Runner is runner next. So essentially, if it's an empty one, will if head is nil, will return head. If head is just one value, we'll see how it tackles those corner cases. But for now, we want to find by the way, do we really need that last odd? Here. Because we have even to connect, we have odd, we just need to connect. We'll find that last odd at the end. So we look at the first value, which is the head. Do we need to do anything with the head? Pretty much no. Although we could say that odd is also a dummy. Yeah, node. And so odd is true. Is odd not is odd. Okay. So if it's true, if is odd, then we connect it to next. Yeah, if is odd next. Is runner. And then we say that odd is odd next. Yeah, else if it's not, so it's even, then even next is runner, even next. So we're building this, and odd is a pointer. Oh, gee, odd is, we're gonna lose them. We're moving the pointers. And well, the head is still gonna be the head. So we still need to return the head. So it's probably, maybe it's not really, but the even ones, that's the thing. We need to remember that first even, that pointer, even head, yeah. We need to remember it. Because it's okay to drop the odd head, but we need that even head. Mm-hmm. So we'll just save even head as that, and even essentially we know what the even head is. Even head is the next, if there is a value after that's the even head, yeah. If head next not nil, then essentially even head is head next. That's what it is. So so we're using two runners, essentially three runners here. We need three runners. We just want to remember that even head. So let me put it a little bit differently. We'll define even head before here. Yeah. We'll say that even head is pointer we can't say, I mean, other thing. Okay, yeah, that's, can't call head next if head is nil, because head could be nil. But odd head is also, odd head is essentially head. So these two pointers, we remember. Now these two dummies, why do we need them? Because with the dummies, we can go and is odd if it's odd. So we'll be building this to lists, and I hope that should work, because we just look at each node and we put it into a separate list. We're building this to lists. Now, at some point, we'll be out. And then the question is, we'll run out of those. Yeah, runner will be out. Runner will be nil. And our odd and our even will be where? That's the question. Because what happens, okay, we say that we attach it first. So that's even, we attach it to the dummy. Yeah, so we have a dummy essentially here and here, the odds and at the evens. So we attach, we link, and once we're done, yeah, those runners, yeah, the dummies are good because they can move. I mean, they can smoothly start and finish, but at the end, what we need to do, we'll have this, the last odd, and then now we can connect. The last odd next is what? Last odd next is our should be linked with the even head. And we need to return what? By the way, odd head. I don't think we even need the odd head because we still have the head. We never move it, so we might not even need the head. We just, because this, yeah, I think this should be what we need, more or less. Heap arena metadata. Wow. Out of memory. Allocating. What? Heap arena. So let's test it. Yeah. we have our dummy. It's odd. And in the first iteration, odd is true. And we connect 1 to it. We connect 1 to it, and we say that odd next is our 1, and odd is our next. So odd is at 1. Same thing happening here. Dummy, even. And so next loop, runner moves from, runner goes like, runner is runner next. Runner was it on 1. And now it's on 2. And what happens here? That dummy, okay, is linked here, and odd moves here. Then runner, it was on 2, and 2 still pointing to 3, so nothing changes here. Yeah, we are now at 3. And 3 is now connected to this. So, and then it goes 4. And then odd is 5, and odd moves here. And runner, when we read 5, next is nil, and we are out. And we need to connect odd. The last odd that we had was 5. We say that odd next is now even had, which we remembered initially, which we saved initially. Even had is had next. So if there is nil values, oh, we can't do that. We need to check if head is not nil first. Then we can call head next. Yeah. By the way, then we create these 2 dummies. We create this flag is odd. Initially is true. And every time it changes, it's odd becomes but at the end, odd next. Yeah, so initially, even had is had next, which is this second value. and we return head. Which has never been changed. Head, so head was the first, the pointer, head is pointing to this, to the odd head, basically. Head is the odd head. And it's never, it never changes, right? Yeah, we never say that head is now something different. So what's wrong with it, and why is it not? It looks like it's going forever. Time limit exceeded. With these, just these two. So runner is head. If for runner is not nil, runner is runner next. That loop, we have only one loop here that could become infinite. And how does this loop become infinite? Because if odd, we connect the current value to our odd dummy. Odd dummy, even dummy, but otherwise, yeah, if even we connect, but the runner moves, yeah, the runner reads them, connects them, but it then moves to the next one. For runner is not nil. So at some point it gets to 5 to this last odd, which points to nil. I really want to see what runner val is, because I don't understand what's wrong with it. Yeah, so it prints allocating heap arena metadata out of memory. Runtime stack. Yeah, so we did print them. It didn't go too crazy about it. Just printed them and that's it. What's wrong with it? So runtime. So in the runtime, it didn't like something. So in general, what we're trying to do is use 2 pointers. Yeah, we have one runner. And we're also building these 2 lists this runner who gets us is our scout, okay? And our scout to get us the by the way, print us this is odd. Also, I want to print it, maybe just to see if it's doing it right or not. Yeah, true, false. Yeah, it's working well. What else can we print just to see what's going on here? Well, we can try to print the odd val, the even add val at the end, yeah. Okay, so 5, yes, and 2, yes. What does that mean? Farina, you're showing the memory usage after starting the server, and then after stopping it. It looks like your computer memory is not enough to do the calculations. What? Oh, it could be my system ran out of memory. What? Seriously? No. How could that be? So I'm checking. No. I don't see any memory spikes. Memory is pretty. No memory pressure. But in the runtime, there is a problem. The runtime error. Out of memory locating heap arena. I want to see. I'm trying to Google it after starting. If I understand what the problem is, maybe I can out of memory. Okay, allocating heap arena metadata. Computer memory is not enough. I don't know exactly what they mean, but but so far the prints show we are fine. It got all the and by the way, the problem is while trying to solve the first example, Higgs. So during the first example, it's trying to do, so it found the head right, The odd, I mean, the odd value is good. It's 5. The 5 and 2, yeah. And the even value is 2, so it's good, and they are linked, and we return head. Yeah, I want to also see what head is. What is head val? Because, I mean, yeah, so it's 1, 5, 2. All good. And by the way, that thing happens. So it looks like the problem happens after. So when we return head, wait a second. What? Oh, gee, we might create a loop here. We need to, so this last odd, the even next is nil. I think that's what we need to do, because yeah, because it was pointing to somewhere. Yay! 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 So the tests went well. Yeah. Yeah, we forgot to take care of the last. Yay! It's nice and fast, and it is solved. It is solved. So our code, well, somebody did it in some shorter code. Somebody did it in longer. This one looks a bit shorter, but we solved it, and yeah, it works. It works for all the cases, when it's nil, when it's just length 1, when it's length 2. Yeah, these dummy nodes were a solution. By the way, does anybody use the dummy nodes? Not everybody uses the dummy nodes. Yeah, but I like them because they allow you to just connect, and and here, yeah, this node was, this pointer was declared at this in the scope, so we could use it here to relink, and we just needed to say what, yeah. Yeah, so these are linked. Yeah, this one needs to yeah, point needs to be the ending. We have to do this because this even had, which we use here, yeah, it might not exist at all. And we do want to remember it. So yeah, solve medium level problem, topic linked list, without extra memory, without using extra memory. Yeah. Found the bug and solved. Yeah. So thank you for watching. Like and subscribe, and we'll see you in the next video.